Okay, we're going to talk about something called the empirical rule. In your book, I think the section on this just says 68, 95, 99.7. Those rules are basically the numbers that go with the empirical rule. So that's just the section title when you read that in your book. Okay, so the empirical rule is based on the normal distribution, which just a bell curve. The reason they call it a normal distribution is the bell curve shape just occurs so frequently in nature that it's considered normal. You know, if you were talking about the heights of human beings, the weights of apples in a truck, human intelligence, they all tend to follow a bell curve. What's more, as we'll find out later on, even things that don't follow a bell curve, we can whip them into shape and make them into a bell curve. The other things about a normal distribution, this is a probability distribution. That means the area under this curve, the total area under the curve, is equal to 1. Probability distributions have a sum of 1. Moreover, this is the population mean. You know, when we're computing things, we have, you know, X bar for sample mean and S for sample standard deviation. But the normal distribution assumes this shape for a population. And so we're going to have a population mean and a population standard deviation. And those two parameters allow you to define the whole curve and allow you to compute probabilities and so on, which we'll do in a minute. But one of the things I want to make sure right now that you understand is that this is a perfectly symmetric distribution. So if the total area under the curve is 1, half of that, or 0.5, is below the mean. It's also the median in the mode. And half of it is above. And so those are just some characteristics you need to kind of understand about a normal distribution. It's probability distribution, total area under the curve is 1, and the area on either side of the mean is 0.5, or half of the distribution. Okay, so the empirical rule. The first thing was 68. That means that 68% of the values in a normal distribution are within 1 standard deviation of the mean. So this one I'm starting with a mean of 0 and a standard deviation of 1. So if I went plus or minus 1 standard deviation, I would have captured 68% of the data. How about from the mean to this point, to 1 standard deviation away? How much do you think, what proportion of the data or what percentage of the data do you think are in that? We know that it'd be 34. It's perfectly symmetric around the mean. And so if from minus 1 standard deviation to 1 standard deviation has 68% of the values, then the area from 0 to 1 standard deviation is half of that, or 34%, or 0.34. So the second part, remember it was 68, 95, 99.7, that 95% of the values are within 2 standard deviations of the mean. From 0 to 2 standard deviations, we're going to have half of the 95, so that's 47.5% as a probability of 475. How about the area in this tail of the distribution, from minus 2 standard deviations down? What do you think that would be for a probability? 2.5? Other people see that? Here's what she did. From here to here is 0.95, or 95%. That leaves 5% in the 2 tails. So those together are going to be 5%, or 0.05, and then there's going to be 0.025 in each one. So half of the 5%, or half of the 0.05 in each tail. 90.7% are within that should be within 3 standard deviations of the mean. So from here to here, we've got 99.7. In the two tails, we'll then have 0.3% or 0.003. And from the mean to either, in one direction, we would have, I'm going to go ahead and put that into a decimal form, divided by 2. That's 0.4985 on either side. And then out here in the tail, 0.003 divided by 2. So this is just the whole thing at once. 60% of values within about 1 standard deviation, 95% said 2, and that should have said 3. Okay, so let's look at a little bit different problem, but using those same concepts here. We have a normal population with a population mean of 70 and a standard deviation of 10. And so what proportion of values are between 60 and 80? 0.68 or 68%. Because, see, we've done 70 plus 10, which is 1 standard deviation, and 70 minus 10, which is 1 standard deviation. It'll be minus 1, but just 1 standard deviation that side. So that's 0.68 or 68%. Okay, so now instead of having it 0, 1, 2, 3s like that, it's just in terms of standard deviations. So that distance is 1 standard deviation because the standard deviation is just 10. So we still have that population mean of 70 and the population standard deviation of 10. So now we want to know what proportion are greater than 80. So the first step is from the mean to this point. Between 70 and 80, that's 1 standard deviation. Remember, if we had gone in both directions, from here to here, we would have had 0.68, but we only went in one direction. So this area in here is 0.34. We also know the probability that we're from the mean up is 0.5. So then this area in the tail has to be the difference between those, or 0.16. On the empirical rule that we went plus or minus 1 standard deviation, we had 68. That would be from 60 to 80. Okay, that's 68. Okay, so, but we only went, if I just went from 70 to 80, I would have half of that before. So this 3,4 is 0.68 divided by 2. And then, remember, the whole area under the distribution is 1, and the area from the mean up is 0.5. So if I've got from the area, this area all the way up being 0.5, and this area being 0.34, then I just have to take the difference between the two to get the 0.16. Okay, so now maybe it might be a little better if I draw this out. It says we still have that mean, and I've got this out here already here, but and we want to go from 50 to 80. So let's say that's 50. And let's say this is 80. So remember, I can just get areas from the mean to some point. So that means I can get this, and I can get this. And when I get those two probabilities, I'm just going to add them together. So from 70 to 80, That's one standard deviation. And we've pretty much established by now that that's 0.34, half of the 68. It's like it was on the previous slide. So now from 50 to 70, that's 2 standard deviations, actually minus 2, just meaning that we're below the mean. And if we went plus or minus 2 standard deviations, we would have 0.95. But we're only going in one direction. So we divide that by 2, and we get 0.475. That's this area in here. So to get the total, we'll take the 475, add 0.34, and we'll get 0.815. What I did on these graphs on the other side here was, on this, I just showed the whole thing from 50 to 80. And then I just broke this up into, here's 70 to 80, that's the one standard deviation, that was 0.34. And then here, I broke just the 50 to 70. That was 2 standard deviations. We divided the 95 by 2 and got the 475. So I did the same thing, I just kind of showed it in a slightly different way. Okay, now what proportion above 80, didn't we? That's 1 standard deviation from 70 to 80. So that's 0.34. And from there up is 0.5. So this is 0.5 minus 0.34, or 0.16. It says we've got a normal distribution with a population mean of 72 and a population standard deviation of 8, and we're going from 56 to 80. First step, most important step in these, is to draw the normal distribution, put the mean and the standard deviation there, and then just draw on the graph what parts you're looking for. In all of these, and we'll start using some other things, the first thing is get the graph. So from 72 to 80, difference of 8, that's 1 standard deviation. 80 minus 72 is 8, divided by 8 is 1. So that's 1 standard deviation, and that's going to be 0.34. So the 56 minus 72 over 8, that's minus 2. So this is minus 2 standard deviations. And we already know that's half of 95, or 0.475. That's just 0.95. And then add those together. Okay, this one's a little bit different. We still have that population mean of 72. And please note that I'm going to label the axis, and you should get in the habit of doing that. It won't always be X. So to know what kind of problem you're working and so on, it'll be a good idea there. Okay, 97.5th percentile. when you take a standardized test, if it says that you're in the 97.5th percentile, that means that of all the people that took the test, 97.5% scored lower than you did. From that point down is 0.975. What's the likelihood that we're from the mean down? That's 0.5 by definition from the mean down. So probability-wise, what's this right here from 72 to X, whatever it is? What's the probability? 975 from here down, 0.5 from there down. What's left here? I just took the 0.975, subtract the 0.5, and there's 0.475 left in here. So we're kind of working this backwards now. Before we started with the number of standard deviations and worked to a probability. This time we're starting with a probability. From here down is 0.975. And then we use that 0.975 and our knowledge of the characteristic of the normal distribution to find that this is 475. So what do you know about 475 in the context of the empirical rule? How many standard deviations is it going to be between the mean and this point X? It's 2 standard deviations. Because remember, well, 0.95 divided by 2 is 0.475. Of course, you could have just taken the 475 and multiplied by 2 to know that you had 95%. So that means this distance from here to here is 2 standard deviations. We started at 72. We're going to add 2 standard deviations. That's going to be 88. So if you scored 88, you would be at the 97.5 percentile. Quite frankly, this is the one, as far as the normal distribution, that tends to give a little bit more trouble on the percentiles, although, so this one we have the ACT test. You may remember that. Has a mean of 24. I actually think the mean's a little closer to 22 than it is 24, but for this we're going to say it was 24. And a standard deviation of 3. And we're going to go from 18 to 27. That distance is how many standard deviations from 24 to 27? 1 standard deviation. So that's going to be 0.34, half of the 68. And from 18 to 24, how many standard deviations? 2. I'm going to go ahead and put minus 2 because it's below the mean. But that's 475. We've added those together a couple of times already. Okay, try and find the 84th percentile. And we've got the 84, 50 below the mean. So how many standard deviations above the mean are we going to be? 34. It's going to be 1 standard deviation above the mean. I'm going to draw it here, but the 84th percentile is going to be 0.34 above the mean. Mean is 24. Standard deviation is 3. And we're looking for the 84th, or 0.84. We know that's 0.5. So that means from here to here is 0.34. That's just 0.84 minus 0.5 is 0.34. 34 is half of 68. So this distance is 1 standard deviation. And so this is the mean plus 1 standard deviation, or 24 plus 3 is 27. So there's two kinds of problems with the normal distributions. One is going to be to try and find the area, find the number of standard deviations away from the mean, and use that and your knowledge of the empirical rule and the characteristics of the normal distribution to compute the probabilities below some point, above some point, between 2 points. And then the other kind of problem is going to be the sort of the reverse of that. Start with a percentile and then get the probability to find how many standard deviations away from the mean, or get the probability like here, the 0.34. And so you're working inside out kind of on that.